Hello, let's take a look at the musculoskeletal levers. Lever is a simple machine consisting of a rigid rod suspended across a pivot point. Function of a lever is to convert linear force into a rotary torque. An axis of rotation or fulcrum is a point around which the lever rotates. Moment arm is a perpendicular distance between the axis of rotation and the line of force. There are two moment arms, the effort arm and the resistance arm. Effort force is a force acting in the direction that the lever is rotating. It is always the winner. The resistance force creates an opposing torque to the effort force, and it is always the loser. Torque equals force multiplied by the length of its moment arm. If we have two equal forces and both moment arms are equal, the torques created will be equal as well. But if we have two equal forces, but one of the moment arms is longer, the force with the longer moment arm will generate more torque. Okay, let's take a look at the first-class lever system. A classic example is a seesaw. Here, the axis of rotation is positioned between the two opposing forces. On one side, there is an effort force and an effort arm, and at the opposite side, there is a resistance force and a resistance arm. An example of a first-class lever system in the human body is maintaining equilibrium of the head. The axis of rotation is aligned with the mastoid process of the occiput. The resistance force here is gravity attempting to pull the head in a counterclockwise direction. The effort force comes from the cervical extensor muscles, pulling the occiput clockwise in order to maintain the equilibrium. The head is in equilibrium when the torques on both sides are equal. Okay, now let's take a look at the second-class lever system. There are two distinct features. The axis of rotation is located at the end of the lever. Effort force is further from the axis of rotation than the resistance force. An example of the second-class lever system in the human body are calves producing torque needing to stand up on tippy toes. The axis of rotation here is around the metatarsophalangeal joint. The resistance force is gravity pulling the body down, while the effort force is produced by the gastrocnemius and soleus muscles, generating plantar flexion force. Notice that in this system, the effort force is much further from the axis of rotation than the resistance force. So if the force production of the calf muscle would equal the gravitational force, the calves would be able to generate more torque. But it's very rare in the musculoskeletal system. Okay, finally let's take a look at the third-class lever system. There are two main features. The axis of rotation is once again at the end of the lever, and now the resistance force is further away from the axis of rotation than the effort force. An example here is a concentric contraction of biceps against gravity. A resistance force, which is gravity, produces a clockwise torque. Gravitational moment arm is located further away from the axis of rotation than the moment arm of biceps, which is an effort force producing counterclockwise movement. Some other examples of the third-class lever system in the body are quadriceps, supraspinatus, and deltoid. It is the most common lever used in the musculoskeletal system. I hope this video was helpful, and thank you so much for watching.